This comes out of section 9.2, differential equations with initial conditions. So in 9.1 we were asked to do a lot of antiderivatives, and we are asked most often to find the most general antiderivative. So for example, if they said find the most general antiderivative of dy by dx equals 2x, you'd say, well, the function must have been x squared and then plus any constant, because if I differentiate x squared plus 2, x squared plus 7, x squared minus 8, I get 2x. In this lesson, they start to give us the ability to solve for c. So for example, let's do this. Still a relatively simple antiderivative to take. We're given ds by dt equals 6t squared, but we're told also that the initial condition exists that s is 7 when t is 0. So if I figure out the antiderivative here, most general antiderivative is going to be that I have two t cubed plus c. If you want to check, take the derivative of it and you'll get 6t squared. But now I'm able to find c because I'm told that when t is 0, s is 7. So 7 equals 2 times 0 plus c, which means c is 7. So my function, I can actually narrow it down to not just the most general, but to a specific function of s equals 2t cubed plus 7. So we're given the initial condition piece of it exists in the title of this lesson, partially because often you're given when t equals 0, when x equals 0, like that initial condition, especially in a word problem when it's, as you'll see in the next lesson, distance, speed, time type problems. But even they can just give us a point on the graph. So that's what happens here in this next example. So I'll go back to this relatively easy derivative equals 2x, but we're told that the original function passes through 2, 9. So I take the antiderivative to say, well, it's x squared plus c. Then I put in 9 for y and 2 for x, and I solve and figure out that c equals 5. So the function that I'm looking at here, y equals f of x, was x squared plus 5. It satisfies the two conditions of the question, that its derivative is 2x, and that it passes through the point 2, 9. So this one says find the curve y equals f of x that passes through 1, 3 and satisfies this differential equation dy by dx equals negative 6 over x plus 5x to the 4 minus 7. So I'm going to go y equals the antiderivative of that, negative 6 ln of x plus x to the 5 minus 7x plus some constant, and do the same thing we did up above. Let y equal 3 and let x equal 1.